Okay, so before we can get into the meat and bones of solving equations, it's good to take a step back and understand the very beginning of why we do things and what they are. So this is all about truth values and truth statements. So in math, we have sentences just like language arts. A sentence in math is a statement or proposal that can be identified as true or false. So 6 is a prime number. That's a sentence. 5 is 1/2 of 10. 6 plus 1 equals 8. I didn't say these were all true, because if you go through, 6 is a prime number. That's false. 6 is not a prime number. It's a composite number. 5 is 1/2 of 10. Well, that's true. And 6 plus 1 equals 8. We know that's false. So what we're doing with these sentences is we identify true or false. Now, let's go get more specific with our sentences. A number sentence is a statement of equality between two numerical expressions. So if you take a look, I took two expressions here. 5 plus 3, that's an expression. It's a numerical expression. And 2 plus 6. And I said they're equal to each other. So let's go look for a second. That statement is grammatically correct. The way I wrote it, the way I read it. But is it true or false? You've got to prove it. Well, 5 plus 3 is 8. And 2 plus 6 is 8. Does 8 equal 8? Yes, it's true. Let's go look at this one. 5 minus 3 equals 2 plus 1. It's grammatically correct. 5 minus 3 equals 2 plus 1. That's the way you read it. That's perfect. But is it true or false? You got to go work it out. 5 minus 3 is 2. 2 plus 1 is 3. Therefore, they're not equal. Do you notice the sign I wrote? You need to state that. Therefore, this statement is false. Don't just force something to equal something because you think it has to be. When you're going through and doing this work for this whole next unit, they might not equal. It might look a little different. That's why we're going through this one video. So let's determine if each sentence is true or false. Justify your answer, meaning how do you know? Okay, so if I look here, 2 plus 4 is 16. 4 squared is 16. Therefore, it's true. Both sides equal each other. Now, when I come over here, 6 plus 4 is 10. So I have 10 squared. Well, 10 squared is 100. So I've got the left side of my sentence done. Let's go to the right side. 6 squared is 36. 4 squared is 16. So 36 plus 16 is 52. Those two are not equal to each other, so this sentence is false. While it might look like they are to you, it's not true. So a lot of you might be sitting there saying, oh my gosh, she's really going to make us go through and multiply these numbers right now? And no, I wouldn't have. When you have something so big like this, what you need to do is look at the left side. You have 83, 402, 365. Go to the other side. You have 365, 83, and 402. So you have the same exact numbers on both sides. Then look at the operations. You're multiplying them all. I can tell you right now that this is a true statement because commutative and associative properties, all they did was move them around. And if you do 2 times 3 times 2, or 2 times 2 times 3, you're still going to get 12. It doesn't matter the order you do it when it's all multiplication. Now, if there was addition thrown in with multiplication, then you're going to have to go test it. But this is a true statement. So now we're getting closer to our equations. we went over what a number sentence is, okay? But a number sentence, that's an example of an algebraic equation. And many of you are sitting there saying, how is that algebraic? Well, an algebraic equation is simply a statement of equality between two expressions, okay? So that's just one type of it. Algebraic equations, they can be number sentences when they only have numbers, but more often, and what you're going to see moving forward, they're going to contain variables. And those variables are unknown. We don't know them, okay? They haven't been determined, but sometimes we'll be able to figure them out. So let's look at this equation, right? So I have 3 times the quantity of the sum of a number and 2, or 3 times x plus 2. And it says that it equals 3x plus 6. Are both sides equal? Well, when you distribute, you get 3x plus 6 equals 3x plus 6. So they look identical, right? Right now, take a second, write down what your thoughts are about what that means for the value of x. Okay, so let's go look. We're going to come back to what you wrote down. But look at this. I want to go through this with you. It might change your answer on the last one. Can you substitute a number in for x that would make this a true statement? Most of you are probably screaming out, yeah, 4. 4 plus 8 is 12. This is what a lot of you did way back in 5th or 6th grade when you started learning how to solve equations. You wouldn't actually do the steps your teacher was teaching. You said, why do I need to do that? I know 4 plus 8 is 12. You're right. But you've seen already, it builds. So now my question is, how many different values, meaning what other than 4, can you plug in there and still have a true statement? Is there anything else I can put in there that would make my statement true? No. Just the number 4. That is the only thing that you can plug in. So sometimes the value of x is just that number. There's nothing else that will work. But if we go back to this one, what did you write down? Did you say a specific number? Did you say a couple numbers? Because what I would have written is that x can equal, and I abbreviated, the value of x can be any number, any real number. There's infinitely many solutions because they have identical sides. So no matter what you plug in, you're going to get the same result. So when your two sides are mirror images of each other, you get all real numbers. Okay? So let's go look at that. I want you guys to practice this. Can we determine what value, now it's a different variable for each one, and that's okay. But what value would you plug in there that would make this statement true? Remember, we're looking at truth statements. We don't want a false one. We want a true one. So right now, try it. What value of m would make both sides of this sentence equal? So I'm sure many of you said, oh, m equals 9. And that's in the past what we've always gotten from students on the worksheets, but you get it marked wrong because it also equals negative 9. 9 squared is 81, but negative 9 squared is also 81. Okay, so let's try that next one. You have 6p equals 3p plus 2p plus p. There's a little work you need to do before you can figure out the answer. But it's all real numbers. Well, how? How is that possible? Because if you simplify, and you should always simplify on both sides, you get 6p equals 6p. So the two sides are identical. So let's try this last one. I want to see if you guys understand it. Are you sitting there saying, is she nuts? Because what number in the world can I add 74 to and subtract 74 from, and they equal each other? You should be sitting there saying, it's no solution. There's no possible way. There's nothing I can plug in that I can add 74 or subtract 74 and they stay the same. So these are basically the three options you'll get when solving equations in this unit. You're either going to get an exact answer, you're going to get all real, or you're going to get no solution. So onto this, many of you don't like to do this. When you solve an equation, you get a number, you write it, you move on. But we need to make sure that we understand how to check what we solved, because our equations are going to get a lot more complex. So what you're going to do is we're going to take this first one. It says x equals 9. I plug 9 in anywhere there's an x. Then I do the work. 3 times 9 is 27, minus 3. 27 minus 3 is 24. Does that equal 24? Yes. Therefore, that one has the correct solution given. Now I'm going to go do this next one. I'm going to plug 3 in anywhere I see an x. Notice what I'm doing. Every time I plug something in, I'm using parentheses on it. That's going to come back to help you a lot moving forward with everything. So order of operations tells me to go from left to right. So 4 plus 3 is 7. Now I still go from left to right. 7 plus 5 is 12. 12 minus 3 is 9. 9 does not equal 20. Therefore, that is not the correct solution. I didn't say find it. All we're doing is checking, does it work? So now I'm going to plug 30 in for x. 30 plus 5 is 35. Divide by 7. 5 does equal 5. So I'm going to put an x there. Now I'm going to plug 6 in. 12 minus 3 is 9. 9 equals 9. So I put an x there. Now I'm plugging 48 in. When I multiply by a fraction, I'm basically dividing by the denominator and multiplying by the numerator. So 48 divided by 3 is 16. 16 plus 5 is 21. In no way does that equal 50. So we wouldn't mark it. So this is not hard, and I'm not saying it is, but for some people, things that are time consuming, we tend to skim over or we take shortcuts. Plugging something back in and understanding how to check it is going to help us with what we do later. So if you understood today's lesson, click like. But remember, summarize. Start this chapter off on a high note. What did you understand? What did you not understand? The not understanding will help us down the road when we prepare for a quiz or a test.